Hello, welcome to another online lecture on distributed networks. In today's lesson, we are going to be looking at WAN concepts. In the previous lectures of this particular course, we have looked at a number of concepts and techniques and technologies relevant to expanding our local area networks, expanding our LANs into much larger enterprise networking environments. We have talked about various concepts such as VLANs, expanding VLANs, interconnectivity, routing requirements, and so on in that regard. From today's lecture and the upcoming lectures of this course, we will be mainly focusing on WAN networks or wide area networks, and our main focus will be around interconnecting these disparate LAN networks or enterprise networks and how we can interconnect those. So, one of the main reasons why we may have to have some form of WAN connectivity in an enterprise environment is that many organizations, many corporate organizations, many large scale enterprise environments can be located beyond a single geographical environment. So, a good example for this could be a university. Our university, even there are a number of campuses located at different physical locations, and people may want to connect to those similar from those different networks to the similar set of services and resources. So, the main campus may be located in one place, there may be other faculties located in different places, and there may even be people who are working from home, teaching from home, and so on. So they may want to interconnect to those common networks through these wide area networks. So, in an organizational environment, this could be about interconnecting different branches or people who are doing things like working from home, telecommuting, that sort of a thing. The main sort of differentiation that we would see between a local area network and a wide area network is a WAN is typically owned by a service provider, like an internet service provider, ISP, whereas a local area network is typically owned by the organization. So, if we take the university example again, the networks that are inside the faculties, inside the campus buildings, belong to the university and are normally managed by the university, whereas the interconnectivity that is between these campuses would be managed by an internet service provider. So, given that these are services provided by a separate organization, it is also commonplace that there may be a particular additional service fee that may be required to be paid for a service provider for having these various interconnectivity capabilities. And one of the other things when we think about these interconnectivities, these wide area network interconnectivities, there may be various types of connectivity that we may have. Things like data transfer, voice transfer, video transfer. So, different types of data can be traveling through these wide area network connectivity. So, again, it doesn't have to be a single form of connectivity, it can carry a multitude of types of information through those network connections. Then the question is, do we really need wide area networks? And the answer is yes, given that we are studying that. But other than that, also there are a number of main reasons why we need wide area networks. Because without those interconnectivities between branches, between faculties, between different locations, the various enterprise LANs, various local area networks of an enterprise would have to operate as isolated networks. We could not have any interconnectivity between these different sites. This requirement is very much there in the enterprise environment, where when businesses expand geographically, when they expand into different geographical sites, there may be a requirement for them to interconnect to the head office or the main branch in such situations. Say, for example, if we take a bank as an example, the bank may have certain networking connectivities capabilities in their head office. But then when they have a new branch opening, now that branch will have its own local area network connectivity to connect all the devices within the branch, but it will still have to connect to the main head office network so that it can be connected to the same systems. So there will be a requirement from the organization point of view to share various types of information, things like customer information, various work related information, systems, certain applications that are available through these networks, databases that are shared. So for those reasons, this type of connectivity would be very essential. In addition to workers, the organization having access beyond its networks, sometimes it may also be necessary for consumers to access these networks. Say, for example, if you are a store and you have an online shop, you may host your online shop on a web server at your shop, at your premises. But now you need to have some form of wide area interconnectivity so that your customers can come and access your services. So it is to expand the number of networks into various geographical locations. It is to interconnect various geographically located workers to the same services or some same systems of the organization, to enable employees to work from home, that type of a scenario, and also connecting consumers, customers to the services that are provided by the organization. So these are some of the reasons why we may need to have WANs for a particular organization. Then when we think about wide area networks, we can have a number of topologies that can be there when we are implementing these wide area networks. So similar to various topologies in local area networks, in wide area networks also we can have a number of different topologies. One of the simplest topology is what we identify as a point-to-point topology. So in a point-to-point topology, what happens is two sites, site A and site B in this case, are directly connected through what is called a leased line connection. So it would be a connection that would be acquired from the service provider, from the internet service provider normally, but we will have a connection between these two endpoints, a direct physical connection through the network of the internet service provider. So that is what we call as a point-to-point topology. It is basically a direct connection between two sites. Another topology that we may see in WAN networks, maybe even more commonly than point-to-point topologies, is what is called a hub and spoke topology. So this may be there when we have a number of private networks to be interconnected across multiple sites. So we have a number of interconnecting networks and we want them all connected to the same hub, so to speak. So these are the spokes, and one would act as the hub. So here what we can do is the hub would be the interface that would share the connectivity between the spokes. Say, for example, if A needs to speak to B, it may go through hub and connect. This type of connection can be established using what is called virtual circuits and sub interfaces, or routed sub interfaces. So again, these can be, there's no requirement for us to have a dedicated physical connection as in how we have in point-to-point topology, but in hub and spoke we can have virtual connections, but as long as we have a similar form of connectivity in this hub and spoke topology. Then another topology that we can have is what is called a full mesh topology. And in full mesh, what we have is so with hub and spoke, one of the disadvantages that all communication has to go through the hub, so it can be inefficient in that manner. So with full mesh topology, what we can have is a number of virtual circuits, and these virtual circuits can interconnect all the sites. So all the sites are connected to each other. So that is the advantage, but the disadvantage is now we need to have a large number of virtual circuits configured and maintained. So each one is connected to each other, and so all these connectivity needs to be maintained. So that could be a disadvantage. But the main advantage compared to a hub and spoke is that there's no sort of central hub which needs to direct connectivity throughout. Then another topology that we may say see in WAN networks, particularly in networks where we need sort of a high level of redundancy, and sometimes even if we want load balancing and that type of requirement is there. So this is again sort of a enterprise environment where certain high availability, redundancy, that type of requirements are there. So we may use this type of a topology where we have, like, say, a number of hubs, and similar to the hub and spoke model, but we have a number of hubs and they are sort of redundant virtual circuits. So a spoke would connect to two different hubs, and so if one fails, the other can connect, or if it can be used for load balancing those links and so on. So, but this would be a much more complex and also much more expensive way of setting up a network. But if those complex requirements are there, or additional network reliability requirements are there, this type of a topology may be used. So that is a dual homed topology. So let's think about how we go into the point of building these larger, expansive, wide area networks with one of these various WAN topologies and so on. The reality is we may not always start with this type of a expanded wide area network from the beginning. Say, if we want to start, say if we are planning a network for an organization, so in this, let's look at an example called span engineering, where they have a particular, so that is the organization that we are going to look at as an example. And one of the main things organizations will look at when they are establishing these networks, interconnectivity, WAN networks, LAN networks, and all of these things, is about how they can reduce the expenses, so not to have too many expensive components involved or aspects involved in the network design, but still being able to increase productivity, profitability, being able to give the flexibility for the workers to work in various ways that it may be necessary. So these are some of the things that will let us decide on what type of network that we may go into in establishing and managing these networks. So let's look at this example of span engineering. So let's take that they start as a fairly small organization, and then at some point they may grow into a large enterprise. So just because they may grow into a large enterprise doesn't mean we have to start with a network that is ready to cater to that large enterprise. But what we can do is we can start the network with expansion potential so that it can be easily expanded, but we don't have to devote a lot of expense at the beginning just thinking that it may grow into a large enterprise in a number of years. But we can keep that in mind when thinking of network design and so on. So for example, they may initially start as a small organization, maybe with a small office, a home office or a small office with few employees, like 4 or 5 employees, maybe even like 10-20 employees, still a small operation, small organization. And within that small organization, they may have some local area networks, they may have some voice over IP phones, some wireless connectivity, some connections to printers and other devices, and then they may connect to the internet through a DSL broadband connection, ADSL or a DSL or some form of a broadband connection to connect to the internet. But it's just a local area network, sometimes wireless, sometimes wired, and connected to a router that is connecting to the internet. A fairly simple network setup. So this is typical of any sort of small office, home office type of a situation. This is fairly common. So most of these IT services, IT devices, even they can be directly brought or leased from the internet service provider. So as a small organization, they may not have their own IT department, IT division or IT support, so they can directly get these services from the internet service provider. So that is possible for a small organizational environment. But then a number of years later, that business has expanded, and now they are located in a high-rise building. Number of floors of the building are being used for that organization, and now they have a fairly sophisticated campus network. So this is the type of LAN network that we have discussed previously, the hierarchical campus network and so on. So we have a fairly largish network. We can call it a medium-sized business network because it is still located within the single campus. But we can have a number of LANs or maybe VLANs depending on how we set up the networks. And so a number of switches, access points, wireless access points possibly, and maybe number of routers, and then all of them connecting to a firewall and a periphery router which may connect to the internet. And at this point, most of the IT support may be carried on site by the local IT department because the organization has grown to a significantly larger scale, and that is again a fairly common enterprise network situation. But then when an organization expands into number of branches, so now they have the main branch that they already had, but now if they go on to open a number of branches in a regional branch or in a different city or like that, if they open a number of branches, now there is a requirement to interconnect all these branches because they may want to share files, their databases, file servers, various say billing systems, HR management systems. So likewise, there may be different systems and information that may need to be shared. So there is a requirement to implement a wide area network. So that wide area network that can interconnect all these sites. So what we can have is all the branches that will connect to an internet service provider or connect through an internet service provider to the internet, and all these will connect through the internet, and the internet will function as the interconnecting WAN, and all the connectivity can go through the internet WAN, so to speak, through the service provider. This can even be happening if some of these offices are located even in other countries, because we are still using the internet. So as long as the internet connection is available, we will be able to set up this type of a wide area network. So again, this is again another common approach that we would take when we think about a larger enterprise needing to interconnect to a number of branches, remotely located number of branches. It can even be globally in different countries. Then, if we think even larger scale, what we would have now is the organization may grow into number of countries. In each country, it may have number of branches in different cities, and they all may need to connect to similar systems. So what can happen with organizational networks is the networks will always evolve and improve and change depending on how the organization is changing. If the organization is growing, the network will grow, the network requirements will grow, and the complexity of the network and what we need to manage that network will grow as well. And in many ways, how this problem would be solved is using some form of secure internet based WAN, wide area network connectivity, that WAN connect all these different locations. And that is one of the things that we would do when we think about designing a wide area network. We'll have to think about all these things. But as I said, we can't always start from that home office thinking that we will go into this type of a global operation, because those are significantly different scales of operation. But at some point, we can start thinking about this growth potential, and we can think about planning or having capabilities and so on in-house to expand into such larger or broader networks. So when we think about WAN operations and in the context of the OSI layered architecture, most of the LAN related operations are going to be around layer 1 and 2, the physical layer and the data link layer. Because beyond that, it is the main sort of WAN technologies are going to be around these. So particularly data link layer, but also the physical layer can change. Say for example, we may go from copper to fiber to copper to fiber, depending on how these different interconnects are happening in the WAN network. We may go through a number of these things, and we may even go through a number of different protocol changes, different WAN technologies as we reach from one end to the other. For example, the head office may be connected to the internet WAN using a fiber connection, a dedicated fiber connection to the ISP, whereas one of the branches may be connected through a ADSL copper line connection, whereas another telecommuting worker, working from home worker, may be connecting from a wireless home broadband connection. So at the sort of last mile, there may be various different technologies, and they may go through different internet service providers in different countries, different cities, and then they may have to interconnect as needed. So when we think about WANs and the OSI model, we are particularly thinking about the data link layer and also the physical layer. And when we think about WAN networks, there are a number of terminologies that are commonly used when we are describing WAN connections and WAN networks. One of the main sort of difference here is, in the context of LAN networks, most of the time all the LAN network belongs to the organization. Whereas when it comes to WAN networks, we'll have that separation point between the LAN network and the WAN network, and beyond which point most of the things belong to the service provider or the carrier network services. So some of the terminologies that you would use to describe these devices particularly, we would talk about customer premises equipment. So customer premises equipments are devices that are normally located within the premises of the enterprise. So these are the devices that are there within the enterprise to provide network connectivity between the sort of inside network. So all the inside networks will come to this customer premises equipment. These are the ones that will be inside the enterprise environment. We would call that the enterprise edge. So all the enterprise network will come to this enterprise edge devices, which you would identify as the customer premises equipments. Then within that, we would have what is called data communications equipment. So data communications equipments are normally the equipment that is going to translate whatever that is within the local area network into what is going to go to the service provider network. In a way, a simple example is this could be a router that is going to connect to the service provider network, could be what we would identify as a data communications equipment. So these are the ones that are going to put the network connectivity or the information that is coming from the inside of the network of the organization into the service provider network. Then we have data terminal equipment. So the data terminal equipment are the devices that are normally connecting the inside of the network to the outside of the network, or they will forward things to the data communications equipment, which would onwards forward it. So data terminal equipments are the sort of last point of connectivity from the inside network before it passes on to the outside network. Then the demarcation point is where we decide what is within the enterprise or what is within the organization and what is outside the organization. So again, this is where we would separate which equipments belongs to the organization, belongs to the enterprise, and which devices belongs to the service provider. Then the last mile or the local loop is the connection from the customer, from the enterprise to the next immediate point of the service provider. So we would call that the local central office of the organization. So the local central office is the next direct connection to which the enterprise is connecting. So because the service provider may have a number of different locations, number of different parts of its network. So we are not talking about those. We are talking about the direct connection to which it goes to. Say, for example, if you are using an ADSL connection, it comes through your phone line. So we are talking about from your home, where does your phone line go into a switchable network of the organization, of the service provider organization. So that is the central office, and the connectivity there is the local loop or the last mile connectivity. So this is we would normally call as what is the last mile connection technology that we are using and things like that. So that is what we mean by that. Then the central office is the service provider organization, that location that we directly connect to. And beyond that, what we have is what is called the toll network, or the broader service provider network that belongs to the service provider. So that is all the interconnectivity that is relevant to the service provider. So normally that is not relevant to an enterprise. Up to the local central office is in some way relevant to the enterprise, because beyond that the organization would not know anything, the enterprise would not know anything, because in a way the data communications equipment is the last one that the organization will have control over, but at least it will know of the local central office in some manner. But beyond that, the toll network is totally beyond the scope of the enterprise. So when we think about WAN networks and what type of devices that we may use when we are connecting to WAN networks, there can be a number of technologies, and depending on those technologies, there can be different types of devices. Say, for example, dial-up internet, and these days dial-up internet is almost extinct, except in very few remote corners of some larger countries like the USA and Australia. Dial-up internet is very rarely used particularly in sort of enterprise environments. But the basic idea is the connectivity goes through a telephone network. So you will have dial-up modems, and then they will access an access server, and that will then put you onto the WAN network. The DSL or ADSL connectivities, again, they go through the telephone network. Again, you have a DSL modem that will go through the telephone network, and then it will be put you onto the WAN network. Then you can have cable modems. These are what would come with internet connections that are coming through cable connections. So typical broadband connections, DSL or cable internet services. So again, similar thing. Again, it will put you onto the WAN network through a WAN switch. Then if you have certain leased line connections, that is when you have this like T1 connections, dedicated leased line connections, so where you will have a CSU or a DSU for your enterprise environment, and then a router that will interconnect your LAN to the WAN. So you will have that. Then within the WAN itself, there will be a number of core switches, multi-layer switches, routers, so various different devices can be there as the backbone of the WAN network. So this doesn't even have to be a single service provider, because you may be interconnecting between different service providers, say one telecom service provider and another internet service provider, and they may be interconnecting through between these service providers. So those type of interconnectivity will also be there when we think about these WAN networks. Another concept that we would come across when we are talking about WAN networks is packet switch and circuit switch networks. I'm sure this is something that we have covered previously in one of the previous courses and in previous networking courses. So this is something that you would know. But the main idea of a circuit switch network is, once a connectivity is established, there is a dedicated connectivity path between those two devices. So particularly if we are connecting using, say, a dial-up internet connection, like a telephone connection, for example, there is a circuit switch network. The relevance to circuit switch networks with WAN networks is we may use some form of circuit switch networks as our last mile technology, like a dial-up technology, some form of public switch telephone network, or a PSTN network, or a ISDN network. These type of things are common in certain networking environments. Then packet switch networks is again something that you know already, but the idea is here there's no dedicated path between two connections, and packets can freely go through various nodes as long as they reach the endpoint as required. So again, and also things like connectionless systems where a particular path is not dedicated, a particular path is dedicated or not dedicated, or a connection oriented systems like a frame relay system. Again, these are things that you already know, and these type of technologies again would be relevant when we are having various WAN networks. And it is much more commonplace for us to use packet switch networks these days because they are fairly cost effective, but there are certain disadvantages such as latency and jitter. But in today's networks, it is almost universally packet switch networks are the most common type of WAN networks WAN technologies that we would come across. Now let's think about what are some of the ways or criteria that we will go through when we are selecting a particular WAN technology to interconnect a particular organization when we are designing their network. So when we think about WAN networks, there are a couple of things that we can have. One is private networks and public networks. So private networks are when we have these type of direct connectivity between these two endpoints. So when we have a leased line, a dedicated leased line, for example, the interconnectivity is directly between the two ends. So things like these are what we would identify as dedicated connections. Then we can also have switched connections, but still things like circuit switched or packet switched networks, things like frame relays or PSTN based ADSL type networks. Those are, again, we can use those technologies but still can have private networks. So that is again only connecting, the connectivity is only between the two endpoints of the enterprise. Only the enterprise edges are being connected through the private network. We can also have WAN networks that are public, where these connectivities are happening through internet. So we are going through the internet infrastructure as our basis for our WAN network. So we may use any sort of connectivity technology, any sort of broadband connectivity technology to connect to the internet, and then we may additionally use certain VPNs and things like that to establish a secure private connection on top of that public internet connection. So again, we can establish a wide area network connection between enterprise edges, but we would still use the public internet as our infrastructure. Whereas in the private side, the infrastructure itself belongs to the organization, or it is dedicated to the organization. Whereas in the public realm, we will use the internet as our underlying infrastructure, and we will build our private network environment on top of that using technologies such as VLANs and things like that. VLANs and VPNs. One of the things that you would see when we are thinking about service provider network infrastructure. So when we think about the WAN networks, but the network interconnectivity between the service providers, here what we would see is they may use even sort of more sophisticated interconnectivity technology. So they will use mostly like sort of high bandwidth fiber optic media connectivities, and particularly these days we are coming across a lot of fiber optic media where these can carry various multiple interconnections, multiple connectivities through the same strand of fiber. So they are wavelength division multiplexing, so various different multiplexing technologies implemented, and that enables a large amount of data being carried between these service providers, which is what would be required because these service providers are carrying network traffic for large number of users. So that type of thing would be there. So these are again things that you would find on the network part of the or in between these service providers. So these may not be more common in sort of the last mile interconnectivity. Even if we have a last mile fiber connection, that may not be as sophisticated as the fiber connections interconnectivity between the service providers. So if we come back to the private WAN infrastructures, a simpler way to establish private WAN infrastructures is what we call as a leased line. There are various standards in different countries. In North America, they are called like T1 and so on, T1, T3. Likewise, the names are such that. In Europe, they are named differently. In different countries, they may be named differently. But the idea is these are point-to-point connections leased through the service providers that would interconnect different endpoints. And one of the things that we can have is we can lease these not only from a single service provider, but we can establish these connections between different service providers, sometimes even between different countries in different continents. For example, an office in New York and an office in London can be interconnected through a lease line from service providers at each end. But given that they are dedicated paths, and depending on the distance that is being covered, these can be significantly expensive and in a way prohibitively expensive for small scale enterprises, and only if it is a very much of a requirement for a customer for an organization that using these lines would be beneficial. Then dial-up connectivity, again using dial-up modems, not so common anymore in in today's networks, but it's what used to be in the sort of yesteryear's network. There may be still sort of realms from the past in certain parts of the countries, but not so common technology to interconnect to a WAN. But still, when we have private WANs, we can still establish dial-up in private WANs as well, but we have all these are considered as local loops, and they will establish a local connectivity between these two environments. Again, when we think about private WANs and using ISDNs or PSTN networks, again, similarly, we are using the ISDN or PSTN telephony network to interconnect between these two organizations, and then we are using that as part of our data transfer. We use those lines for our data transfer between these two entities. So again, the technologies and the different standards that we may use will dictate what is the speed that we can get and so on. But again, these are also still not that commonly used anymore, like dial-ups, PSTNs, ISDNs are not the standard way of connecting to WANs anymore. They are, it may be possible, it is feasible, but it's not the common way we connect to WANs anymore. Then another type is again frame relays. Again, we need to establish frame relay. Again, The main problem with establishing private WAN connections is they are going to be significantly expensive, um, depending, unless it is essential for a particular organization. This is not something that we would go about implementing, because doesn't make much sense economically. We won't get much of an advantage unless there's a specific requirement there. Um, then asynchronous transfer mode or ATM networks, again, the idea is we are going through a service provider network, but what we have is an ATM switch at both ends, and so at from this up to this point it is a private network, and this point it is a private network, and this is going through a service provider network. But so that is the main idea of ATM, and you may have covered this previously in certain networking courses. But the idea is it can be forwarded here, the packets can be broken in here from the switch, and then they can be reassembled there. So that is the basic idea of an ATM network. But again, an example for a private WAN infrastructure. Ethernet WAN is an interesting concept when it comes to WAN technology. So the idea is, this is what we normally call as metro Ethernet at sometimes, or when service providers as what is called a metro Ethernet. So the interconnectivity is still in sort of a still in sort of an Ethernet type of a connectivity, but then so the interconnectivity can be established, but through what is called a metro Ethernet connection. So comparatively, this can be sometimes expensive. It can be less expensive, but the infrastructure should be there. So there are certain advantages compared to the previous sets of private WAN infrastructures, but this is particularly mainly feasible when we are thinking about fiber optic based Ethernet. So it can be fairly distant, can be fairly carried over fairly longer distances, but still operate as a Ethernet connection, or a WAN, but still a WAN connection. Then there's what is called multi-protocol label switching networks. So these are basically the idea is, because all of these things may connect using different technologies. So different service providers, different endpoints may connect through different topologies, different technologies. So this multi-protocol label switching network would interconnect all these things and interconnect different technologies. That is the basic idea there. So it can support a wide variety of WAN technologies. So like, say for example, a T1, a T3, a metro Ethernet, a frame relay network, all of them can connect to this common switching network, and then all of those can be interconnected there. Another common, not rather common, but another important type of interconnectivity that we may have when it comes to WAN connections is the satellite connection. So the satellite connections, particularly very small aperture satellite connections, are things like when organizations have some dedicated or sort of remote locations where there's no interconnections or there are no internet connectivities. This is fairly common in, again, certain larger countries, like say in the remote outbacks of Australia, for example. There are large parts of that country that doesn't have any internet connectivity. But so if you need to have some branch or some operation, some interconnectivity from that particular location, you need to connect through a satellite. So so you may use satellites for interconnectivity, and that would be your sort of the last mile for your WAN network. But sort of the disadvantage, or one of the main sort of factors to consider, is the cost, because using a satellite for these type of connections could be cost, and all the speeds are limited in certain situations and so on. So we have to keep that in mind, but that is also a plausible technology depending on the requirements of an organization. Say, for example, if it is a government and it has some weather stations and some other critical infrastructures that are located in a remote location but still need interconnectivity, they may use this type of a situation. Then when we go into the public type of WAN infrastructures, this is when we are connecting through the internet. So any of the technologies that we can use to connect to the internet, we can use here. So we can use our DSL connections, ADSL type connections. We connect from a router to our modem that will dial to the internet service provider, and then we will be onwards put on to the wide area network, and then we may connect to the other parts of the network. Say, for example, if you are working from home, you may connect through your ADSL connection to the internet and to the wide area network part of your organization, and then onwards to the organization network. Similar situation with cable networks, cable connections. So cable internet is not common in many countries, but it is common in certain countries. But it is fairly similar to how internet connection is bundled along with the telephone connection in a DSL, ADSL situation. In a cable modem and cable connection, it is bundled with the television cable connection. Wireless connectivity is a fairly common type of public connectivity that we have these days. There are a number of technologies that are there, things called municipal Wi-Fi. So these are sort of much wider area Wi-Fis that are interconnecting large parts of a city, for example. So you may be connect to that. So if a city may have a number of public Wi-Fi hotspots, you can connect to that and then onwards to the internet and to the wide area network. You may connect through things like WiMAX. These are again, WiMAX was gaining popularity at some point in the past, but not so much anymore. But it's again a wireless connectivity technology. Satellite internet again can, if we connect to the common satellite network, and then that can be a public part as well. We can use satellite for a private connection or a public connection depending on what satellites and connectivities that we are using. So those are there. And like things like 4G broadbands and 5G and all these things are again mobile internet, home broadband, and all these things are wireless type public WAN connections. Particularly 3G, 4G, and going onwards 5G. This is a fairly common way of connecting to internet. And you may learn about particularly about 3G, 4G, and 5G in the mobile technologies course. I think that will be running in parallel to this. So again, these are again in a way connecting to the internet and then onto a wide area network. Another common thing that we would use, or common technology that we would use across all of these wide area network infrastructures, particularly when we are using public WAN infrastructures, is VPNs. So VPNs are a way to establish these tunnel connections between two endpoints. So even if we are going through a public network, after we are going through an encrypted VPN tunnel, it is essentially a private connection. It can be seen as a dedicated private connection, a virtual private connection. That is, it's a virtual private network or a virtual private connection, but it is essentially going through a public network. But using encryption and the basic technologies there, we can have a private network there. And one of the common things that we are seeing a lot these days is many organizations are moving away from dedicated connections, lease line connections, and going on to these type of internet through connectivity, and then establishing VPN connections because they are much more cost effective, the security is much better, You can scale up much easily because you don't have to establish new dedicated connections. You just need a connection to the common internet, and then you are free to connect to the other endpoints within your network and establish the virtual private network. And it can work on various different technologies as well. So an organization may connect two sites. They may connect fiber to the service provider. A worker may connect through their 4G connection, but still all of them can establish these VPN tunnels and be part of the organizational environment. So you may have a VPN gateway in the head office, and all of them will be connecting through that. So, as a network designer, when you are tasked with procuring a network connection or a network setup for an organization, and when you have to choose a particular WAN infrastructure, WAN technology, there are a number of things that you can think about. So, that is, what is the purpose of this particular wide area network? What is the geographical scope of the wide area network? And what are the type of traffic that is going to be carried on through this network? So things like, is it going to be interconnecting local branches in the same area, or are they going to be international or different regional connections? Do they need one-to-one connection between all the branches, or is it enough all the branches are connecting only to the head office? Is that enough? If the head office is going to be a hub and all the connections are going to go through that, so, and what are the type of traffic? So is it going to be, what type of traffic? That is it going to be heavily sort of data traffic or video traffic? Would these be interconnecting the VoIP calls between the environment, between the branches? So what that may have different requirements about quality of service and things like that. So these are some of the things that you would consider when you are thinking about, as a network administrator. You will try to ask these questions and get a better understanding of the organization and their requirement, and then you may choose one of the previously discussed technologies to implement or procure as a wide area network technology. Then one of the other main questions that we may want to answer is whether we want to go with a private WAN, or are we okay with using public infrastructure. So private infrastructure would be very secure because it is under our control, but then private WAN would be more expensive, whereas public infrastructure may be not so secure because it is shared, but the cost would be significantly less. It will have a lot of flexibility to connect to different sites. It will have flexibility to connect using different technologies. People working from home, different branches with different technologies, different countries, they can connect to the same public internet infrastructure and interconnect. Possibly having certain VPN technologies there. If we are using public WAN, then it is essential in a way to have VPNs. So then where do we establish the VPNs? And also one of the other factors that would decide is, like, you may not always have all the type of connections. Say for example, not every part of the country will have fiber internet connectivity. Sometimes you may have to go with some other technology. Some places you may not be able to get wireless connectivity. You may have to go for a wired option. In some remote places you may have to go with a satellite based option. So again, these other factors will also depend on what is available, what is cost effective. So again, you have to think about these sort of factors as well when you are thinking about choosing a particular WAN link connection. So as part of this particular lesson on the LMS, you may find a particular activity that you can focus on. So just have a look at that. Do a bit of a research about the WAN technologies that are available currently. What is the prices from different service providers and things like that. So you may do that as an activity and you can find the details on LMS. So that's mainly about it when talking about WAN concepts, some of the basic WAN technologies, and what are the factors to consider when choosing between different WAN technologies, private and public WAN technologies, and the advantages and disadvantages of some of these, and compared to one or the other. That's mainly it for today's lesson. If you have any questions, you can ask through the usual communication methods, and we will continue with our discussion about WANs in the upcoming weeks in this course as well. So until next time, thank you for joining in today's lesson. See you. Bye.